Hello, followers of my YouTube channel. Welcome to today's tutorial. Last time we have seen about creating HRUs using QSWAT, yeah. And as you have seen, in the last time we have seen how to add the land cover map, the soil map, as well as how to classify the slope in order to specify the number of HREs we should have to provide a threshold value for those parameters. Yeah. So we have seen those things when we are going to create HREs. Okay, so last time we have seen those things, and one thing what I have not told you is that this QSWAT has a special feature than that of the SWAT model because of different aspects. The first one is that of the available crop types in the database. If you see the database for this QSWAT, there is a special feature. For instance, if I showed you the database from this one, yeah, we may have additional crops. Okay, so let me say crop, and let me show you what I have seen here. Yeah, I am working some researches, for instance, for my case, by integrating this QSWAT with that of SWAT model, because in most land cover types there are shrublands, but those shrublands has not exact name, this crop name on the SWAT, yeah. But under this QSWAT database, we can access it. For instance, if I filter here, shrubland, yes, a shrubland here, SH, yes, you see shrubland. You can have a database for the shrubland, and the crop name for the SWAT is QSWAT is shrub, SHRB. And I will expect that a lot of additional crop types may be available, which is not available on the SWAT. And we can integrate, we can copy this database and paste it to that of SWAT model in order to incorporate this shrubland to that of the SWAT model. For instance, I am copied this one and provide for my research. Yeah, if I showed you here, let me show you my database. Yeah, I hope here is it. This one is let us see the crop here. Yeah, yes, I will provide this is the copied one to this database, and I have worked on that on my research. Okay, so you can integrate the SWAT with that of, you see this one. I have integrated this QSWAT with that of the SWAT model. Therefore, you can do such special features within that of QSWAT and the SWAT. You may have an access when you are seeing some features on the QSWAT. Okay, so having this, let us proceed to today's tutorial on edit inputs and run SWAT models. Already we have done the watershed delineation, so we can specify the numbers of watersheds, and you can have an access to merge if you have a small watersheds. In addition to that, we can add reservoirs under this delineating watersheds, and we have done HRUs, HRU creations. And today let us use edit inputs and run a SWAT model. Click on this. Therefore, in order to edit this thing, you should have to prepare the meteorological as well as other additional parameters. Okay, basically the meteorological data are the necessary inputs. So in order to do that, you should have to click on this connect to database. So you see it says database connection is successful. Now after you are connecting to the database, those icons, the right input tables, edit SWAT inputs, and the SWAT simulation are now active. Before that, they are not active. Therefore, you can write input tables here. You can edit the input tables. I hope you remembered those things under SWAT. Okay, so under this right input tables, go to weather station information. Okay, weather station information. Before that, you should add as well as this WGEN or the weather generator data into the database. Okay, into your database. So to do that, open your folder here. Okay, QSWAT practical one. Under this one, then there is this one. Then there is the weather generator. Okay, WGN user here, and you can add your WGN under this one, or you can import similar with that of the soil. Okay, let me close this one, and let me rename this one. Let me rename user, rename it as 1. Let me use as 1. Okay, and right click on this, and let me import from Excel. I have all the way where this WGN user from Excel. Sorry, from desktop. Here is IDS SWAT, and there is sample data set here. You see the WGN Robit data is prepared in such a way. We have seen the way how to prepare this WGN Robit. Okay, so open and okay, and proceed here next. Okay, so we have the object ID, the row, and the likes. And next here, similar with the previous one, with that of the soil, you should say that no primary key, and next here, yes, import WGN Robit. So save the import and save it. We can have Robit data here. You see, now I have added an information for the WGN in such a way. Okay, So if you add those things in such a way, let us select the weather generator here is WGN user. Okay, there may be some error here. Wait. Okay, one thing what I missed here is you should have to rename this WGN user one, the previous one. It is the previous WGN, but when I import it, you should have to rename as WGN user, not Robit. Okay, that may be the mistake. So because actually we are importing the users, yeah. When you come to this one, when you come to this weather generator data, you should have to select WGN user here. So the station count is 1 because here you see one station is selected for this WGN. That is why. Okay. Therefore, we have extracted our WGN user, and the other is relative humidity data. So actually, we have a relative humidity data here, and let us select the relative humidity from this one. Okay. So we have a climate Robit here. So we should have to give the lookup tables now, because by default when you are giving the lookup tables, it extracts the data, yeah. So we are importing the humidity range, humidity gauge, sorry. So the relative humidity Robit here is this one, open, and the rainfall data here is in rain gauge, daily data. The location here is PCP Robit station, and here the solar radiation data, yeah. Solar radiation data here is Sol Robit, yeah. And the temperature data here is the climate station data, and the temperature Robit station is this one. And what remaining is the wind data. The wind gauge is this one. So wind, yeah. I hope we have given all the datas, yeah. Rainfall, yeah, daily, wind, temperature. All right. So say okay. So you see, it is importing the available datas. Now the process is completing, it says. Okay, so we have done this one. By the way, we can access the datas. Let me show you the highlight for the datas here. You see PCP Robit station, for instance. You see this one is the lookup table for the case of PCP. PCP Robit PCP is this one. This is the data. This is the initial date 01. That means 01 January 2019, yeah, is the starting date, and we can have some space at the end of the datas. So we have you should have to arrange our datas in such a way. Yeah, it is very simple, and I hope you have seen from the SWAT tutorials. Yeah. Okay, so if you have write those weather stations, and now we can write the SWAT inputs. Okay, select all, and we can have an access to create tables. Yeah. No. Yeah. Do you want to write existing? Yes. Let me rewrite it if it is working. Do you want to rewrite PS? Yes. Reservoirs. Yeah. If your work is correct, the red color is changed to that of the green color. It says completed. Yeah, so then building selector tables. Now we are done on writing the input tables. Okay, and you can let me come up with this one. Actually, yes, we can access the parameters. Okay, so if you are importing or providing the available data, what is expected from you is that running the SWAT model. Okay, we will come up with edit SWAT inputs when we are working on calibration and validation. So now let us run a SWAT model. Okay, run a SWAT model. Our data here is period is from 1990 up to 2031-3. You see, sorry. Let me do on the monthly time step, and let us provide with a 2-year number of skip year. That means warm-up period. I hope you know about warm-up period, yeah. And let me select as this 24-bit release in order to save our time. Okay, let me use a debug. Okay, if there is error. Okay, so click on setup SWAT run, and it is finished. So run your model. Now we are going to see some outputs. Okay, some outputs from a SWAT model. Okay, so the SWAT run is successful. Say OK here. Okay, and we can cancel this one. Actually, we have run and go to this SWAT simulation and read the SWAT output. Okay, so for instance, I would like to read output from the reach, the sub-basins, as well as is from a Charius and sediment, and also you can tick what you want to visualize. Okay, if you want to see the output for the management, you can check this one, and we can import the files. Okay, import the files to the database. Now we are importing the database now, and before you can see can save your simulation, you can run and see the SWAT checker here. Okay, we can visualize the hydrologic cycle. You can examine here similar to that of the SWAT model, and what you see here. Okay, therefore under this you can see the hydrology as well as the sediments, the nitrogen cycle, the phosphorus, the plant grows, and the likes, and the landscape nutrient loss as well. So we have this one. The number of HRU is 42. Yeah. The basin is 1, and the output time step is monthly time step in order to save our time. In the watershed area is this much kilometer square. Alright, so we can have the hydrology here. You can see the average curve number as well, and see the precipitation, yeah, 1400 millimeter, and there is evaporation and transpiration. Yeah, there is surface runoff. You can see the hydraulic cycle in this case. And as there is some warm-ups here, the water yield may be excessive and surface runoff may be excessive. You should do on these warning messages when you do calibration and validation. Okay, after calibration and validation, those errors may be solved. Okay, so I have this, and let me save as the save current simulation as let me see as sim1. Yeah, let me sim1 before calibration. Yeah, before calibration, and let me save it. So we have successfully saved our data, and we have this one. So we can cancel now, and we have done what is expected from inputting data. So we can exit from this one, yeah, and let us save our project here. Therefore, if you go to this file under this one, we have a scenario here which is called sim1 before calibration, and you should provide this table in out for the case of SWAT cap in order to calibrate our model. Therefore, using such things, we can do this edit SWAT inputs and run SWAT model. And the fourth step here is you can see the report as well. Yeah, and there is QSWAT parameters. Yeah, so the fourth step here is visualize your work. Okay, one important thing here is you can visualize your reports. For instance, choose scenario here, and I think it is better to come with another video on this one because it may take our time. Okay, so I think the third part of this tutorial about edit inputs and run SWAT is very interesting, and for the next tutorial we will see how to visualize our outputs. This is the special feature of this QSWAT, special features of QSWAT. So it is enough for today, and have a nice time. Don't forget to share those videos to your friends. Okay, and if you have any questions, please put under the comment section. Have a nice time for today, and bye.